it's like P4, you can get about 60 per second. On AMD Opteron, about 70. On Beetle's laptop over here, if you want to own his laptop, you can get about 70 per second on like an Intel Core Duo. And that's actually like, that's actually 35 per core or something like that, right? So with one of our little compact flash cards here, we can get about 430 per second.
We beat all of you.
And in this sort of cluster, we get about 65,000. On one of these cards, we can get about 1,000 per second. So in a cluster like this, if you fill them up with these, you get about 15,000 per second. So yeah, basically almost like 100 times, well, about 60 to 70 times faster than Josh's laptop over there. So pretty exciting. Supposedly Aircrack has some like MMX optimizations, and you can get about 100 per second on like a top-of-the-line P4. But we haven't really looked into that too much. Just wanted to throw that up there.
And so notably, the whole point of like those performance numbers is just to show the idea that yes, actually using programmable hardware to accelerate the process that we're trying to do does work, right? It's a feasible solution to what we're trying to make happen.
Yeah. So results. I threw all this stuff together, and RenderMan contacted me, and he decided that he wanted to compute hash tables for top 1,000,000 passphrases for the top 1,000 SSIDs. And so I had, this box laying around, and nobody really was buying it. And so I was just like, hey, I'll give you a shell on it and just crack away. And so one thing that's kind of funny is RenderMan sent me this email saying like where he got all these passphrases from. And I guess 43,000 or 430,000 of them are from like Mark Burnett and Kevin Mitnick. And they're actually harvested passwords from some systems they hacked supposedly or something. And they padded out to 1,000,000 passphrases with like a bunch of other stuff, and stripped out all the short ones because the passphrase has to be between like 8 and 64 characters. So RenderMan took all this stuff and he tried computing it on his like lab of workstations. I don't know. He said his cluster, so I assumed it was multiple machines. And it took him about a month to compute all the stuff on his cluster. And then he found out that every word in his word list had return characters at the end of each word, and they weren't filtering it out in cowpatty for some reason. So yeah, after computing for a month, after computing everything, he found this out. So he sent me an email, asked me for some help. Help me! And this system here did it in 2 days. So pretty quick, about 48 hours it took. So I'm going to do a quick demo. This kind of sucks because I can't see the screens over here, so I'm just going to start it up.
Stand in front.
Oh, you're going to stand there?
Yeah, I'm
okay.
going to stand in front.
So demo time. Yeah, but I'll start this up just so.
Can people hear me on the mic still? Yes? Cool.
Yeah.
I'm going to, in order not to favor one side too much, I'm going to try and ambulate.
Yeah, this will be a little difficult, but.
You want me to hook it up in the back?
What's that?
Can I hook it up in the back?
No, I can hook it up. I'm just trying to get things set. Okay. Wait, let me start this up first, just so it's actually there.
It's beeping.
Okay, it's starting, so you can switch it over. So I took cowpatty, and because we're basically running one cowpatty instance for every card in the machine, I just set up a little script that creates a screen session and like creates screen sessions for every single instance of cowpatty, and automatically splits up the dictionary and just runs it. Can you see it over there?
Yes.
Okay. So
you've gotten the PSK Family Movie Night.
I just found it.
Yes.
Oh, okay. All right. Yeah. Well, that was going through like the 1,000,000-word thing, and it takes only like about 10 minutes or something to go through the whole thing, 1,000,000 words or something like that. So yeah, it's kind of I can't really see it from here. So so essentially, the PSK for this, these are all the ones that's tried. These are the different key numbers. The PSK is Family Movie Night, 4,769 passphrases tested in 10.7 seconds, 445.78 passphrases per second. Yeah, and that's just one instance. There's also 7 others going on.
Right.
So yeah, another screen session.
Switch.
They automatically die whenever one of them finds.
You're on 3 right now.
I'm on 3.
Yeah.
Oh, okay, cool. Yeah, I think all of the other ones are dead because they didn't find anything.
Okay. Yeah.
So yeah, I don't know.
Is that it?
You know what, let me try. Does that work?
Yeah.
Yeah. Okay. So you can see it going
Starting
on.
up cowpatty instances, and now it's going through keys. 23, 25, 2600. So
I think that's like towards the end of the word list, but it should.
It's in
find
R's
it
in
another
essence.
instance.
Yeah.
What's
Yeah.
that?
Family moving it again.
Oh, okay. Yeah. So that's the demo. It does it really fast, and
Yeah. Basically, it's not impressive, which means how fast it is.
but yeah, if I ran this on the actual machine here, you know, we'd be waiting here for the whole lecture, trying to, you know, wait for it to complete. So.
All right. You have your screen back?
Yeah. And you can also use genpmk. I don't know if you've heard of that, but that generates basically a dictionary kind of like file that you can later use for all your cracking stuff. So it's kind of like a rainbow table for WPA, and that's what we use to generate all these pre-computed hash tables and stuff. So you can use this to do that. As long as you have, you know, the SSID and a huge word list, you can just have it run and crunch on things. Ah, yes. So Beetle down here in the front actually found this little tidbit over at layer 1, and he was pretty excited about it. It's pretty sweet. What's that?
You're probably seeing that one easier.
Oh, okay. Yeah, so he found out that there's actually this airport utility in OS X that lets you feed it a PSK and an SSID, and it'll actually generate a PMK. So basically the whole PBKDF2 function. And so he just whipped together a little Perl script, and we could totally make fun of him on this because he just found some bugs in it.
And we should.
And we should, yeah. I mean, like, look at this. He's like assigning this variable like in the middle of the for each loop here.
Let me get down with the laser pointer. Hold on. Let me point it out.
Well, no, wait. Actually, that's not too bad. But
No. I mean, I know it. Oh.
But he's not using my, and my God, what an animal.
Yeah. clearly, you know, not yeah. But you know, like Perl, it does work. So.
Yeah. So he's getting about 20 passphrases per second just with a ghetto Perl script that he threw together in OS X. And so yeah, this is ghetto PMK, basically the ghetto version of cowpatty. And
right, single-threaded.
Yeah, single. So yeah, that's all of the WPA stuff. I guess if you have any questions, you can save it till the end. Johnny's going to come up here. I don't know if you know Johnny Cash, if you saw his wireless thing.
If you don't know him yet, you will know him now.
Yeah. So he wrote Airbase, and I modified his stuff to run with FPGAs, and so he's going to give us a small rundown on what Airbase is about.
Thank you very much.
Yeah.
Here, I'm going to give you my microphone.
Oh, okay.
Oh, I hate these.
Pardon me for the microphone switch here. She's singing dance.
Yeah, that's all right. I don't like clicking into anything anyway. Oh, okay. I feel important. I've got a mic. I feel like I'm on the news or something.
Speak normally.
Okay, so can everyone hear me? No feedback? Sounds good to me. All right, so I'm the one that created Airbase, which is pretty much just a suite of 802.11 tools. And I had written a lot of 802.11 stuff before, and they were all their own little program. And finally, I said, to hell with it, and put a big library around them all and started rewriting them all. And a few months later, I had what I called Airbase. So started out with JC WebCrack, which is a distributed web cracker. JC AirCrack, which was just a C++ reimplementation of AirCrack, and anybody who's read AirCrack knows it needs a reimplementation, but aside from that, God, it's ugly. And then there's a whole bunch of tools. I'm probably going to spend too much time talking about the rest of the Airbase, just the hardware accelerated a bit, which at this point is just JC WebCrack, though in the future, JC AirCrack, hopefully the near future, JC AirCrack will be hardware accelerated as well. That'd be cool, huh? So, yeah, I got a lot of tools, using them with wireless cards. That's what I was doing before for my other talk. It was fun. JC AirCrack. JC AirCrack pretty much comes with a re-implementation of everything you've come to expect in AirCrack, you know, arrow dump, PCAP2IVs, merge IVs, everything. It also comes with some really elite ANSI animation, which I can't show you on the PowerPoint, but it looks really cool when you see that key found thing pop up.
We're going to show it later.
Oh, we are?
Yeah.
Oh, bitchin'. I guess you'll get to see it,
Well,
huh?
not the AirCrack stuff, but the...
Okay, yeah, I guess you still get to see the animation. Cool. So you'll see the animation. It started out in AirCrack. Anyway, the stuff at the bottom is actually kind of useful. It shows you which of the 17 statistical attacks, or 16, I guess I didn't do the last one, has has actually landed you some points when you're trying to crack the key. So attack number 0 here, which is the original, got us a lot, and attack number 1 got us some. I think that was Hikari's, and then there's some more. 15 got you some, the rest didn't really do much. Okay, so JC Web Crack. JC Web Crack is actually the hardware accelerated portion of Airbase at this point. Comes with 3 different executables. There's JC Web Crack D, the Web Crack client, and the Pico client. So this is a picture of JC Web Crack D. This is the daemon that sits listening on your server, waiting for clients to connect, and it's just going to check out a chunk of the key space to you know, whoever connects. So it's kind of like SETI at home for cracking web keys, right? And a lot of questions I get asked is, why would you ever try to just brute force a web key when you can run a statistical attack? So how many people here have successfully run air crack? Could I see? Like crack somebody else's network? Yeah, like 8. Okay. It's a pain in the ass. Everybody talks about, oh, statistical attacks, they're so bad, crack any network. Doesn't matter if key size. And that's the key. The statistical attacks work on 128-bit keys, and you can't brute force a 128-bit key. But on a 40-bit key, I wrote this program and I ran it on my cluster I built for a school. Yeah, I guess I shouldn't get into that too much. They cut me off a while ago, which is why I started messing with FPGAs, because I couldn't get to it. Anyway, so the cluster had, I don't know, 13 Athlon 2200s. So that's pretty modest, I guess, in terms of clusters, but it's cool to have for myself. And you could crack a 40-bit web key in like 24 hours. It was actually pretty cool because it was really like right up to 24 hours was the worst case scenario. So 1 day turnaround, no hassle. Like you start up the program, you want to crack your neighbor's network or something, you check the next day, and either you got it and it's a 40-bit key, or you haven't and it's a 104-bit key. And so there's 2 advantages of this. One, you don't have to sit around collecting packets and scratching your head. Why did it exit? Do I need more IVs? Do I need more data? Should I de-auth someone? What the hell is this program? Is it re-injecting ARP packets, or is it doing nothing at all? You know, it's frustrating cracking stuff statistically. It's a pain in the ass. So if you have a 40-bit network, this is, in my opinion, a lot less of a struggle. And the other advantage is there's no way to know if your neighbor's network is a 40-bit or a 104-bit one unless you brute force the entire 40-bit key space, and it doesn't work. At that point, you know you've got a 104-bit network, and you can bust out the cranky statistical attacks and sniff packets for a week and get lucky. So currently, this is how it's set up. You have JC Web Crack server, the Web Crack client. Oh, and then you have a bunch of Web Crack clients, sorry, and they're all just checking out chunks of the key space, SETI at home style. But once you throw in an FPGA, you have, you could have a bunch of client, computers. Maybe you've taken over your school's computer science lab. Maybe you've got a cluster. But however you get them to do it, you can have a bunch of normal computers connect and check out the key space, as well as having, if you've got an FPGA loaded into a laptop, you can have it check out key spaces as well. And the server doesn't care. It just sees one guy doing a lot faster. No big deal. So the current architecture is this, and I'm going to show you the future architecture in a minute. So right now, JC Web Crack D has 2 different programs talk to it, the Pico client and the Web Crack client. And they talk the same protocol, but it means that the Pico client has to talk to the hardware, and the Web Crack client doesn't know about it. And it would be more elegant if you just had one program that knew how to do everything. And also right now is JC AirCrack, you see, is talking to Airware, and so is the Web Crack client. And Airware is my library that does all things wireless. And so it's using the library to crack the web key. It's got functions in there to try this key, brute force this, or whatever. So what I'd like to do is, instead of just having the